Here you see a question from IIT JAM 2022, and here you see a limit, and this question is actually a combination of limit and series. So I can rewrite the same as I show you. Equals to limit n tends to infinity, and here you see, here in the numerator there is over root n plus 1 minus over root n, and you know n is not the variable is k, so the numerator can be taken outside the summation sign. So here will be n plus 1 over root minus over root n. I have taken the numerator outside the summation sign, and here I write the summation sign, and it starts from k equals to 2 goes to n, and here it remains in the numerator, it will be 1, and in the denominator you see k. ln is natural logarithm square. Okay, now you see I have a space here, and here I type same but with opposite sign, over root n plus 1 over root n plus 1 minus plus over root n plus over root n divided by the same thing, that is n plus 1 over root plus over root n. And if you now simplify this one, then you will have this thing I show you, lim n tends to infinity, here will be 1, and in the denominator it will be over root n plus 1 over root n. And now here you see limit is written one time, we can write this limit separately. Here I type again limit n tends to infinity, and here you see the summation, it goes from k equals to 2 to n, and here is k inside the bracket ln k square. Now you see that the value of this thing is 0. Okay, so 0 into this thing, then you can say quickly that the answer will be 0, but I say that it is not necessary that one factor is 0 then the whole thing will be 0, because this one is a series, and series may be convergent or divergent. If divergent, then its value may be infinity. So 0 into infinity is not equals to 0, you should know. So to get the answer 0, we have to prove that this series, you see the series here inside the red blue enclosure, this series, we have to show that this series is convergent. Then the whole thing, the limit given in the question will be 0, and in that case the option will be D. So Let us now prove the series whether it is convergent or divergent. For that, I have to clear the space. You see, I have cleared the space, and one thing here, limit is n tends to infinity. Now let us see the terms of this series. If you see the first term, then k equals to 2 will give us the first term, and the first term of the series will be 1 by 2 into 1 by ln 2 square. Okay. Now the third term will be 1 by 3, 1 by ln 3 square. And you know that first term is greater than the second. This means that as you go from one term to next term, the value of the term decreases. So if you consider the terms and you consider the terms as a sequence, then this sequence will be a decreasing sequence. And in this case, you know, whenever we have a sequence of positive terms and the terms are decreasing, then we can use this test. I write here this test. Here I type the name of the test is Q.No.14, or simply we can use this test, integral test. And the next question is how we perform this test. For this test, we assume this one, you see, this thing as fk. Okay, and evaluate this integration fk dk, and the limit will be here k equals to 2 to n. So the next step will be 2 to n, and at the place of fk there will be k ln k whole square, and here will be dk. So it's very easy integration if you go to evaluate this one. And remember one thing, that this n tends to infinity. Here we have to type n tends to infinity. So if you evaluate this integration and you tend n to infinity, then the value will be a finite number. So it shows that the series is convergent. So series is convergent, then as I said earlier, that 0 into a finite number will be a 0 obviously, and then in that case the correct option will be D. So this question is done now.